Acetaminophen or paracetamol is a medication used to treat fever and pain. It is one of the most commonly used legal and over-the-counter drugs throughout the world. It has many brand names, but it is more commonly known as Tylenol. While it was first synthesized by Harman Northrop Morse in the late 1800s, it was not introduced to the general public until the 1950s. In the University of Strasbourg in the late 1800s, two doctors, Arnold Chan and Paul Happa, mistakenly administered acetanilide to a patient with intestinal parasites. The drug reduced the severity of the patient's fever. They published this discovery and acetanilide was introduced into medical practice in 1886. However, it could not be used as a fever-reducing drug, as it turns out excessive use led to toxic side effects in the blood. Acetanilide had two derivatives, phenacetine and paracetamol. However, due to a faulty conclusion, phenacetine was preferred as it was thought paracetamol had high toxicity like acetanilide. Then, in 1948, Bernard Brodie and Julius Axelrod disproved this claim by demonstrating that it was responsible for pain-relieving and fever-reducing properties of both acetanilide and phenacetine. Thus, paracetamol was introduced to pharmacies in 1955. There are two known ways to synthesize the compound, one of which is the classical method. There are two reactions. The first produces para-aminophenol, and then using that to create paracetamol. The creation of paracetamol is accomplished through the acetylation reaction of the para-aminophenol with the use of acetic anhydride. Within the classical method, there are two variations. The first variation uses nitric acid for the nitration of phenol, producing 4-nitrophenol, which is then put through a reduction reaction, which then gives you para-aminophenol. The second variation of the classical method takes nitrobenzene and electrolytically reduces it, forming para-aminophenol. The other method, created by the chemical company Celanese, is a series of reactions utilizing direct acylation of phenol, leading to a ketone group being added to the phenol. Then, with hydroxylamine, the ketone is converted to a ketoxene, and finally is acid catalyzed through the Beckmann rearrangement, thus forming paracetamol. An interesting thing to note is that paracetamol can undergo a hydrolysis reaction. Now, a hydrolysis reaction is a reaction in which a water molecule breaks apart a large molecule, and this reaction produces an amine, or in this case 4-aminophenol, and a carboxylic acid, or in this case acetic or ethanoic acid. In regards to its relevant molecules, acetaminophen contains 3 functional groups. Now, a functional group is essentially a group of elements that help dictate the chemical and physical properties of the compound it is attached to. And in this case, acetaminophen has 3 functional groups: a hydroxyl group, an amide group, and its main structure is a benzene ring. As stated before, acetaminophen has many brand names. It is known as Apra, Bromo-Seltzer, Children's Tylenol, among others. Chemically, it has a multitude of names. One of the 2 IUPAC names it possesses is N,4-hydroxyphenyl acetanilide, and its other chemical names include N-acetyl para-aminophenol, para-acetaminophenol, and para-hydroxyacetanilide. Due to the presence of the hydroxyl group and the amide group, the compound is polar. Both the hydroxyl group and the amide group allow the compound to exhibit hydrogen bonding, which is the strongest intermolecular force, not to mention the 2 other intermolecular forces that it possesses, allowing it to have a relatively high boiling point. Once acetaminophen is orally ingested, it is metabolized in the liver, leading to 3 metabolic pathways. These 3 pathways each produce different products, which then lead to the pain-relieving effects. In 1982, there were a group of sudden deaths associated with the consumption of Tylenol. All victims took Tylenol that, unbeknownst to them, was laced with cyanide. In response to this, Johnson & Johnson, the seller of Tylenol, changed how Tylenol was being packaged. They changed it from capsules to caplets, which made other pharmaceutical companies do the same with their other over-the-counter drugs. Furthermore, after the murders, US Congress passed the Tylenol bill, reaching the FDA and essentially changing the laws regarding drug packaging so that they could not be tampered with. If it wasn't for Tylenol and these murders, there would not have been stricter laws regarding drug packaging, potentially causing many more deaths and further distrust over drug manufacturers.